In an attempt to create more transitive proofs, I'm trying to video record different ways to use the transformational approach in establishing proofs of some of the very typical things we've always proved very algebraically. Vertical angles is one of those, and I've already displayed, if you watch the other video, a way to do it using a rotation. When I often ask students to use a transformation to describe why this angle is the same as this, many times instead of the rotation they say, it's a reflection. And so I say, a reflection over what? Now if they can think that through, I'm willing to go through the proof with them. And many do say it's through the angle bisector of the adjacent angle. So let me put that in there. So I would first say that angle M is not just any, line M is not just any line. It is the angle bisector of both of these angles, and we'll call it M. So if you were attempting to prove this, that basically by reflection that these two angles are equal, we'd follow a similar path to rotations. But it would say a reflection over line M, where M is the angle bisector of angle CEB and angle AED. So first we establish we're going to do a reflection. That reflection is over a particular line called the angle bisector. Now you might write it this way, or you just might say it's the angle bisector of the adjacent angle, or whatever you want to do. Now let's describe what that reflection does. A reflection over line M where that maps, here we go, B onto ray ED, B prime. So we know that because this is the angle bisector, this ray will map onto that ray. So B will map onto the other ray in that angle. So, I don't know, it maybe say here would be our B prime. We would also know that it would maps A onto its other ray, ED, calling it A prime. So maybe here. And we would know that it would map E onto itself. Now if you watch the other video, this is almost an identical proof. The angle bisector here would map this ray onto this one onto this one. That's what it means to bisect an angle, is to cut it exactly in half down the middle. Therefore, a reflection would map these onto each other. Then we get B onto its opposite ray, B prime, A onto, not its opposite ray, B onto the other ray of that angle, A onto its other ray. And then we would follow a very similar argument that we did before. Angle BEA is congruent to angle B prime, E prime, A prime, because reflections are isometric. And it would also be true that B prime, E prime, A prime will be equal to D, E, C, because it's physically on the same rays and the same vertex, because they share the same rays and vertex. And what I'm saying is, look, A prime and D are on the same, E and E prime are the same, B prime and C are on the same physical rays. Therefore, using our transitive argument, BEA is congruent to DEC, just as we wanted to prove, because of the transitive property. Property of equality. Which basically says if you have an item equaling an item, it equals something else. Because of this, you transport yourself through. BEA congruent to DEC. This is a very similar style of proof, but used a reflection. All a student would have to do is first establish what is that line of reflection. The properties of an angle bisector are strong enough to tell us that this line would be a line of reflection that would map B onto the other ray of that given angle. It's a nice little proof. Good thinking, students. Keep it up.